Hey guys, I recently attended the annual convention at the Early TV Museum in Hilliard, Ohio. Now, one of the most commonly asked questions I get when I talk about that museum is what is going on with picture tube rebuilding. I hope to answer those questions in this video. After this intro will be a detailed walkthrough of the picture tube rebuilding facility at the museum, a look at the equipment, and a description of the steps involved in rebuilding a picture tube. Before we get into that, I want to fill you in on a few other details. So there are a few obstacles preventing us from doing picture tube rebuilding right now. One is time. With the equipment at the museum, there are certain stations that can only do one picture tube at a time, and some of those processes take hours. The museum's only open a few days a week, and the guys who have the knowledge, the desire, the will to start rebuilding picture tubes don't live near the museum like myself. So say we were to do it at the annual convention, we can maybe rebuild 2 a year. So there's personnel, but beyond that there's materials. When you rebuild a picture tube, as you'll see, you need certain things. They get replaced. We need glass. We need a button with leads coming out of it. But biggest of all, we need a new electron gun assembly. They aren't being made anymore, at least not from any reliable sources we know of. We have a limited supply. They came from Hawkeye, some came from a rebuilder in France, RACS. I took a brief look at the inventory while I was there, and it was a little discouraging. Some of the electron gun assemblies seemed to be damaged, or some of the getter material had fallen out. But also, it's hard to say, what am I looking at? Am I looking at a gun that's black and white versus color? That's usually pretty easy to tell. But what era is it from? Is it for a Trinitron? Is it for a Delta gun? Is it for an inline gun? Is a black and white gun for something from the 30s, the 40s, the 50s? Is it for a predictor with the small neck? Is it for the early ones with a larger diameter neck? What's the filament voltage? What's the filament current? There are a number of variations. So if you're going to rebuild a picture tube, you have to find all the right parts to fit together. A new glass stem, a new button, a new electron gun assembly that's all right for that picture tube type, has the same type of glass, etc. We need to take stock of what inventory is there, decide what's good, what's bad, and start practicing. All right, let's get into a little more detail about the facility at the museum. And be sure to check out the description, which will have links to the museum with more info and links to donate. Thank you. Hey, good news. We found somebody who knows a lot more than I do, and he's going to walk us through the process.
Hi, I'm Matthew DeSaro, Board of Directors for the Early Television Foundation and Early Television Museum in Hilliard, Ohio. One of the really cool things we have here at the museum, which maybe one of the only ones on public display in the world, is an attempt at a recreation of a CRT rebuilding facility. This was very common in the 1940s through the 90s for repairing CRTs because they were expensive, hard to replace, and you could actually repair the electron gun and make them work again. So I'm going to do my best to walk through the process. I've never done this myself in person. Nick Williams is the one who has really gone into depth, and he has some excellent videos on the Early Television Museum website. So if I get a few things wrong, I apologize in advance, but I figured it would be better than nothing to go through this. So the first thing that has to happen when you get a CRT is we have to clean it carefully. It's very important that the picture tube be properly cleaned, because if it's not clean, if it's dirty on the outside, once it's evacuated, that outgassing from that dirt could actually get into the vacuum, and once it's cut open, it's much harder to clean. So we have a large wash tub. I think this thing was essentially, purpose built out of a cow pasture, tub. I don't entirely know. And the tubes would be thoroughly washed. There should be a rubber mat in there. I don't think we have that quite there. So from there, from washing the tubes, the next step is to remove the old gun. So when I talk about an electron gun, well, what am I talking about? It's a device like this here. And you can see it's on the end of a little glass button. So these are new parts, if you will, replacement parts. So these are the parts that emit the electrons, and then this is the part that will be welded into the neck. Here's a used gun. The back of this tube got smashed, but this has again been removed. So how was that removal accomplished? accomplished? Well, that's what this tool is for here. We have an auto transformer and a high current transformer, a step down transformer. And we've hooked that up to a piece of nichrome wire in this tool here. So literally what we would do is take the wire, and I'm going to do this very gently, it's an extremely rare tube, wrap it around the neck like that and put it under tension, and then you'd adjust the voltage here. As the wire gets red hot, it creates stress in the glass and cracks it. The glass will crack in a very uniform circle around the end, and at that point the vacuum will leak in slowly so that the inrush of air doesn't blow the phosphor off of the screen. There were other ways of opening these, of course, that people came up with, but this was the sort of nominal standard method. Once you're to that point, the tube's full of air, the air's contacted the gun, and the gun is not easily welded back on again from the way those work, so you're sort of past the point of no return at that point. You pull out the gun, you've got the tube. So we've now got a tube with no gun, like this 15G here with an open neck. Okay, what do we do from here? How do we proceed? How does this work? Well, the next thing we have to do is get a new piece of glass onto the end of the tube. So as an example here, you can see there's a couple of different welds on this piece of necking glass and then another one here. I believe these were done at the factory and this was done as part of the rebuilding process. So here is, thank you very much, got one for you. This is a piece of necking glass, also called a flare, because it flares out on the end like a little horn of a musical instrument. So what we would be doing is welding this onto the end of the neck. And the purpose of the flare is, and I don't think this is quite the right, no, it's not quite the right size, but you get the idea. This new gun, or this is actually called a button, the gun would be attached to the button, would then go into the end of the flare and be welded in place. So the next step would be to weld on that piece of necking glass before we put the gun in. Now, there's a lot of questions about what are all these various tools. These are all various types of glassworking lathes. So this is what's known as a horizontal lathe. You can see we have these, looks like leather and asbestos pads that clamp the sides of the tube, and then the face would go up against this bar here, and that would be tightened with actually a pneumatic cylinder. Okay, and then the flame comes out of this whole series of nozzles over here by the, I guess if this is the headstock, that would make this the tailstock. We have a very similar arrangement over on this vertical lathe. So in the vertical lathe, picture tubes hanging down here, the flame is coming in from the side. Both work, you sort of have advantages and disadvantages depending on the size of the tube and the style that the glassworker is familiar with. So that's the next step. So at that point we would have this, if you can imagine here,
There's some back here.
Oh, here we are. This is a perfect example. It's a 10D. And you can see there we have the flare welded onto what's left of the neck. Now, that's not a perfectly good weld. Obviously, we're practicing here, trying to learn. But we've got that welded on. So at that point, the next step is to put the gun itself into the flare to make the finished tube. And this is arguably the trickiest part of the whole process, certainly the riskiest, because the guns are quite precious at this point. We don't have very many. We've got these boxes with some of them, but they're usually types that aren't needed very often. And so you only really get one shot at it. The goal is, again, to heat the flare with the flames to cause this to flow in and attach to the gun, and then this flared part to come off. Now again, this isn't the right size for this flare. This should not slide all the way in. It should end up sort of right about at the base of the flared part. But it's still the same idea. Oh, here, this is probably closer to the right. There we go. That looks, again, this is a little too big. You want it right at the base, but it's closer to the right idea. So, okay. So how is that done? Well, depending on how sophisticated the shop is, it would be done either on a more a different lathe or the same lathe that the necking glass weld was on. In fact, sometimes the gun could be welded in on the same heat that the necking glass is welded on. Again, it depends. Here we did it in 2 separate steps. And again, just to focus a little bit more on the trickiness of the glass working, we have to preheat everything very carefully because large changes in temperature, especially with a soda lime glass, leaded glass, so I guess soda lead crystal, but it's not like Pyrex, which is famously temperature resistant. This stuff will crack if it's not heated very evenly. So that's why we have all the very even flames. There are ovens which are outside that you could preheat the tube in. There were various procedures and processes that the glass workers had figured out in order to do this reliably. Again, if you want to see a video of the actual, welding, I'm not going to be able to reproduce that for you guys live, but it's on YouTube. Again, look up Nick Williams. Okay, so then we have this machine. Now, I will admit that I am not a perfect expert at this, but I'm pretty sure that this machine is similar to the lathes, a way of doing that critical welding of, again, I could be wrong here, critical welding of the gun into the device. Here, instead of rotating the tube, you must rotate the tube when you're welding the glass in order to get a good seal, but for this part, not necessarily so absolutely necessary. So you could mount the tube here, have the flames coming in from all sides, manually turn the tube and get that critical weld. So these are essentially kind of the same machine in 3 different configurations. So now we'll pretend for a minute, I don't know quite where this came from, you should put it back, it's actually a precious one. Now from there, we've got the gun welded in, we think we're done. Well, no, we're totally not done because we don't have any vacuum in there. This is, after all, a vacuum tube. So that comes to the really tricky bit, the scary bit, where you have to hook up what's called the evacuation nipple, right, on the back side of the tube. This has to be hooked up to a vacuum pump. The whole tube has to be baked in an oven up to approximately 200 C, hot. These things are not, everything in the tube has to be rated to those high temperatures. And left there for, the longer the better, to get all the residual gas to come out of the tube. And so you're pumping on it the whole time. And during that heating, the envelope of the tube has to survive the heat of the furnace and simultaneously has to hold the vacuum. Okay, so we're back after changing locales here. So the next step in the process, after we have the gun mounted into the flare, into the neck, with the evacuation nipple on the gun, we have to bake the tube, sucking on it with the vacuum pump. So what does that actually look like? Well, so this is an oven that was custom built, modified from one used for CRT rebuilding by the museum. And if we look inside here, we have a couple of critical things here. We've got support here with genuine asbestos, which holds the tube. And then we have a flange adapter down here to connect it to the vacuum system. So if we go down here, we can see the start of the vacuum stuff. So let's go through real quick what we've got. We've got a roughing pump, which is an oil-based pump, roughing pump, oil-based pump, which works like you'd sort of imagine. It's got a chamber that gets and valves of sorts that get bigger and smaller and pull the air out. So that gets most of the air out, but that doesn't get the vacuum to a high enough grade vacuum to actually make the electrons have a long enough, what they call mean-free path, basically, to run into anything to make a good tube. So the second device is what's known as an ion pump, and that's this funny cylinder here. It has essentially no moving pieces, and it works by having some very expensive and very specialized oil that will absorb and then release residual ions inside the gun. There's a could give a whole lecture on that, but that's the simplest thing. You can think about this if you, as the viewer, happen to be an expert in vacuum. This would have been the predecessor to the turbomolecular pump, which we would use for a high vacuum pump today, which is mechanically, by momentum transfer, gets to the very high vacuums. But again, we're doing this while we're pumping. That's absolutely, totally dead critical, because if we don't pump and heat at the same time, we're not going to get all that residual gas that's absorbed, adsorbed, not absorbed, into the surfaces of the inside of the tube. So, the other things we have here is a vacuum gauge for measuring the amount of vacuum that we've achieved. We can close that real quick. There's the oven, and we have. Oh, actually, there's another turbo pump. Ion pump right back there.
Yeah, we're gonna go through.
And then this is a very high-powered, essentially microwave amplifier, which I'll talk about in a minute when we come back inside. All right, so now we're back inside the rebuilding room proper, having moved away from the oven. So at this point, just to finish up, the tube would be evacuated in the oven. We'd while still pumping and still hot and everything looking good, you'd come in with a torch and a glass working tool and kink off the evacuation nipple. That's why on a completed tube you see that little pinched off nipple. And then you can let it cool and remove the tube from the oven. And at that point you think you're done, but of course you're not. There's always another step in this process. So there's kind of two different things that have to be done after the bake out before the tube's good. One of them is what is referred to as flash the getter. So what exactly is that referring to? There's a lot of misconceptions about this. If we look at a gun here, I can find one here that has a
little cup, right?
Has a little getter. Well, let's just look at this one here. Bring the camera off to the side. You can see that little ring. Observe there's a little ring right inside the neck there. That ring, have you found one? This ring here is also a getter. So what is this actually consist of? What is a getter? What a getter is a little bit of highly reactive metal. Think cesium, potassium, all those super reactive metals that just want to get that extra electron. And so what that does is it will react with any residual gas in the tube and help extend the life of the tube. So the reactive metal is in a little sort of cup portion of that ring, covered with a layer of non-reactive metal to protect it until you're ready to use it. At that point, by inductive coupling of a high-frequency signal, so we're thinking like a radio transmitter, which was pointed out the other device, we can heat that ring by inductive heating, so an inductive cooker, or frankly how a transformer works, so your Weller soldering iron. You can heat up that ring to the point that it gets red hot and evaporates off the highly reactive material to then go onto the inside of the tube to make a blackish or silverish material, and that's that highly reactive getter. Okay, so there's the basic story. So you've got the thing gettered, and then the other step that has to occur is what's known as activating the cathode. So, and not to get too horribly technical here, because I do understand that this is a more general purpose video, but the basic idea behind an oxide cathode, which is what CRTs and receiving tubes in general use, is that it is a piece of metal covered with oxides of highly reactive metal, similar to but different mix to the getter. Because these metals are so reactive, it means that they have a low work function. Where work function is the amount of energy that's required to rip an electron entirely free and send it down the tube. It's a sort of an unfortunate twist of fate that these happen to be instantly destroyed by air because they would react with the air, and therefore we only can activate them once they're in the vacuum. Yeah. So the idea of activating the getter is that we're going to heat, sorry, not the actor, I apologize, the cathode. We're going to heat that cathode up to a temperature that's higher and hotter than it would normally operate at, and that causes a chemical reaction to occur which takes the oxide that was placed down and converts it to the reactive metallic form so that it can release the electrons. Now, it actually occurs only at the surface in an incredibly thin layer, and so when we are rejuving, quote unquote, a tube, what we're actually doing is stripping off that top layer, hoping that there's still some of the cathode beneath it that can create the same reaction, make a new fresh layer. And again, the reason the tubes fail typically is that that highly reactive metal has reacted with stray gas and become no longer having that low work function, therefore few electrons come off the gun, and therefore, etc.
Yep.
Dim picture. So that's what we have here. So what this machine is a combination of a fancy tube tester. You can see we have the emissions rating cut off, the heater, and a high-powered power supply to heat that getter. So, heat the, well, you can, I believe this one also has the ability to heat the getters as well, but to heat the cathode. And there are a couple of ways it can be done. Sometimes you can reactivate them simply by running the heater of the tube itself to heat it up to the temperature to activate it. Other designs of guns would require, again, an inductive external heating source to achieve the same result. And so what we're doing there is watching the performance of the tube while we're doing this process to try to make sure that it all comes in and that we don't overheat the getter.
Sure.
Yes. So that basically ends the process as written. But I want to talk about a few other interesting pieces of equipment that we have here that are used in various parts of the tube rebuilding that might not be quite so obvious. So this is a very cool thing. This sci-fi looking weapon, pew pew, is actually for looking at the strain left in glass.
Oh, wow.
So you have a light source on one side and two cross polarizers on the other side. It's called a polarimeter. When you look through the neck of the tube, placed between these two and through the polarizers, you can see patterns if there are strain lines in the glass.
Huh.
And this will allow you to check to make sure the welds are of, it isn't too much strain that's going to cause the tube to fail. So that's a pretty nifty thing. The other device we have, which is one of the scarier things here, you see a very high voltage on the end of a cable. This is part of the evacuation process where we're actually trying, after it's been evacuated, actually running a high voltage arc through the side of the glass to the gun electrodes, and we're trying there to describe it essentially as a cleaning process of getting the residual bits of conductors that might have ended up on the inside of the glass during the manufacturing process to burn off, so we don't get arcing from the high voltage elements inside the gun, inside the neck of the tube, to other parts where they shouldn't be. But it's a terrifying process here with extremely high voltage and high current.
Is that what they call knocking it? Or is that a different process?
I'm going to be really honest here and say I don't know.
Okay,
I haven't done it myself. And then the other thing I wanted to point out here, which is more of a piece of specialized equipment, but is worth noting, this is a specialized portable leak detector. So the idea here is that we would apply helium to the outside of a piece of vacuum equipment while pumping the vacuum equipment down, meaning pulling the air out of it with the vacuum pump that's built into this, such that we can succeed in measuring the leak rate of the tube. So not something that was normally done. This is a piece of laboratory equipment, but extremely useful if you're trying to troubleshoot your process and understand why you have a tube. This is a 15GP22, probably the most famous CRT in our community. And this was, I shouldn't probably say of course, but this was the tube that RCA used in the CT100 and was the basis for everything that came later in color television. Now the problem with these tubes is that there is a piece of glass here, the faceplate, the bell, right? You've got the bell, the faceplate, and they didn't yet have the frit glass, which is a special low temperature glass to weld, well, not really weld, solder, if you will, braze, use your favorite metal term, called fritting in glassworking, frit these two pieces together. So instead, what they did was they used a glass metal seal between this ring here and the face, and a glass metal seal between the ring and the bell, and then they electron beam welded those two pieces of metal together. Now, the problem is that glass metal seals are always tricky, always have it, and one that large is really tricky. So if these glass metal seals leak, you get air in the tube and it ruins the thing. So the challenge has been, and there have been various proposals, but no one's really managed to succeed in a large way, of rebuilding these and resealing that gap. So as part of understanding, where the leaks are and how to troubleshoot these, we have the leak detector. Fun little fact, I don't know how widely known it is. In my very informal, as they say, Kai-by-eye statistics of looking at the serial numbers of the surviving CT100 tubes, the ones that have not leaked, they almost all appear to be replacements. Not all, but almost all appear to be replacements. And indeed, the 21 CT55, the follow-on model, still has leaking problems, but not nearly as much as the CT100. So I believe, based on that RCA was aware of this issue and was optimizing their process for making these glass-to-metal seals. And so the second batch of 15 GP22s that were made as warranty replacements primarily were much more likely to survive because they had optimized the process. Again, I'm not going to say everyone, I'm not even going to be able to cite hard numbers on that, but just an informal view of the collectors I know who have these have all, all except for one that I know, have had a second gen tube. I have one good, I believe good CT100 tube in my collection, and it is indeed a warranty replacement. So, and just again, before we finish out here, I just wanted to point out here, this is big ol' roundy, and again, you can see the new design where we have the frit glass between the bell and the face. And as that same technique of using the frit glass is what was done on color tubes up until the end of, black and white really, until the end of the era. The old way of making a black and white tube where there was a glass-to-glass weld between the bell and the face quickly fell out of favor because it required a great deal of glassworking skill, where this involved smearing some paste on and baking it. So, and then again, just real quick, the reason that you can just use an all welded one for glass, black and white, and you need some sort of a joint here for colors, we have to secure the shadow mask and the screen, if there's a separate screen and everything inside there. So hopefully that helps go through this. Again, I would encourage everyone who's watched this video to this point and enjoyed it to please check out earlytelevision.org and consider making a contribution either financially or in kind to the Early Television Foundation and Early Television Museum. We are the premier U.S. museum of television technology. So not so much into the old shows and the actors, although that stuff's really cool. A lot of us really like it. We're aiming to preserve the technology that led to television as it exists today, which I am afraid to say is somewhat of a poorly preserved history, despite its extreme importance to modern society, leading, of course, to video games, to mass media as we know it. Unlike the computer revolution that was done largely by universities and academics that, were very good at preserving things, most of the television stuff was done by private companies, and there's a little bit more of a blue-collar flair to a lot of this stuff, and it didn't get put in museums. So if you want to help contribute to the preservation of this incredible part of our collective technological history, please check out the museum, consider joining as a member, and I will see you next time. Thank you.